Okay, for our second lesson on kinematics, we're now going to look at a past HSC question. In this example from the 2002 HSC, we're given a diagram and a bit of a story about what's going on. So a car and a jet are racing against each other from rest down a runway. The car increases its speed v1 at a constant rate, while the speed of the jet is given by v2 is equal to 2t squared. After 5 seconds, the car and the jet have the same speed of 50 meters per second as shown from the graph. Okay, a couple of key things we need to highlight from the actual statement here. The first one is they start from rest. Okay, so that will give us our initial conditions. For part 1, V1, find an equation for the speed of the car in terms of t. Now looking at our graph, we can see V1 is that straight line. Obviously it has a y-intercept of 0 and it has a gradient of 50 over 10, so the equation of the car V1 is 50 over 5 t seconds, or 10t. So that's our equation for V1. How far behind the car is the jet after 50 seconds? Well, how far behind is asking us to find the distance the car is behind the jet. So we now need to find the expressions for the displacement for both the jet and the car. Now, if V1 is equal to 10t, then to find the displacement, so we've been given V1 is equal to 10t, so to find x1 we simply have to integrate that velocity expression with respect to t. And if we do that, we get 5t squared plus c. We now need to find that initial condition, and since when t is 0, x1 is 0, that tells us c is 0. So we get an expression x1 is equal to 5t squared. So we found x1 is equal to 5t squared, and now we need to find an expression for v2. Now we've got an expression for v2. v2 is 2t squared. So x2 will be found by integrating that, 2t squared with respect to dt, because if we differentiate displacement to get to velocity, then obviously we integrate velocity to get to displacement. And if we do that, we get 2 on 3 t cubed plus c, and once again our initial conditions, x2 is equal to 0 when t is equal to 0, because it started from rest. So our expression for x2 is 2/3 t cubed plus, not plus c, because c is 0. So we've now got two expressions for x1 and x2. So now we need to substitute into those two expressions. So when t is equal to 2, we get x1 is equal to 5 times 2 squared, which is 5 times 5 squared, which is 125, and x2 is equal to 2/3 times 125, which is 250 divided by 3. So obviously the 250 on 3 is bigger, therefore difference is equal to, the difference is 125 minus 250 on 3, which gives us a difference of 125 on 3 meters. That's part 2 done. For part 3, we're wanting to know when does x1 equal to x2. Solve that for time. So we've got 5t squared is equal to 2/3 t cubed, or 2/3 t cubed minus 5t squared is equal to 0. Take out a common factor of t squared, and we get 2/3 t minus 5 equal to 0. So 2/3 t is equal to 5. or t is equal to 0, which was our initial condition when they were at rest. So t is equal to 15 on 2 seconds. So after 15 on 2 seconds, the jet catches the car.